In this lesson, we're going to talk about how to use coordinate geometry to prove a quadrilateral is a rhombus, a square, and a trapezoid. So we're going to start with the rhombus. And just like when I talked about the rectangle yesterday, there is an efficient way to show that a quadrilateral is a rhombus. Remember, a rhombus has all four sides the same length. So the most efficient way to do this is to just find the length of all four sides. So you use the distance formula to find the length of all four sides. Once you have that, you can use that information to show it's a parallelogram and a rhombus, because you're going to show that all four sides are equal, and that is sufficient to show that it's a rhombus. There really isn't a more efficient way to do this. Another possible way is to first prove the quadrilateral is a parallelogram and then find the slopes of the diagonals and show that they are perpendicular. So you prove it's a parallelogram, you find the slopes of the diagonals, and then you show that they're negative reciprocals, so they're therefore perpendicular. But if you think about this, it's probably going to take a lot more work than just finding the distance or the lengths of the four sides. So here we have quadrilateral snow, and we have its coordinates. We're going to add coordinate O is 0, 4, and W is negative 2, 1. We're going to prove that it's a rhombus. So I'm going to find the distance of each line segment. SN is going to be 3 minus 1, so that's 2 squared, plus 2 minus a negative 1, so that's 3 squared, which gives you 4 plus 9 inside the radical sign. So that's going to be radical 13. Okay, and O, we do the same thing. And O is going to be 0 minus 3. So that's negative 3 squared, plus 4 minus 2, so that's 2 squared again. And again, the inside, this is a 9, that's a 4. So that's also radical 13. OW, let's look. OW is going to be negative 2 minus 0, so that's negative 2 squared, plus 1 minus 4, so that's negative 3 squared. Remember, when you square a negative, you get a positive, and once again, we get radical 13. So I'm guessing that WS is also going to give us radical 13, but you have to show your work. You can't just write it down. You won't get credit. So negative 2 minus 1, again, that's negative 3 squared, plus 1 minus negative 1, so that's a 2 squared, and again, it's radical 13. So your final statement, all sides are equal. And a quadrilateral where all four sides are equal is by definition a parallelogram and a rhombus. Therefore, snow is a parallelogram and a rhombus. It's important to also state it's a parallelogram, because you need to state it's a parallelogram first and then a rhombus. Alright, when we proved a quadrilateral was a rectangle, we did all four slopes, and that was sufficient, because from that you could get its parallelogram and the fact that you have a right angle. When we prove a quadrilateral is a rhombus, we do all four distances, because that's sufficient. But now when we do a square, we got to do a little bit of both, because a square is both a rhombus and a rectangle. So you can either find all four slopes and 2 consecutive sides, or find all four sides and 2 consecutive slopes. So I'll talk about both of these choices. In the first case, if you find all four slopes, that's enough to show that we have a rectangle, because you can show that it's a parallelogram with one right angle. And then if you have 2 consecutive sides that are congruent and it's a rectangle, you have a square. So this shows it's a rectangle, and then with that it's going to be a square. In the second case, we're showing that it's a rhombus and then a square, because finding all four sides congruent that's going to show it's a rhombus because it's a parallelogram and a rhombus, and then two consecutive slopes, that's going to be the 90-degree angle to show it's a square. So either way will work. So I guess you kind of decide which formula you like better, the distance formula or the slope formula, because you're going to do 4 of one and 2 of the other. So I'm going to do slopes this time. So I'm going to do the first method up there. I'm going to show it's a rectangle and then do 2 consecutive sides to show it's a square. So the slope of BA is going to be 3 minus 0 over 4 minus 0, so that's going to be 3 over 4. The slope of AR is hopefully negative 4 over 3. If I look at it, I get negative 1 minus 3 over 7 minus 4, so it's negative 4 over 3. That's good. There's my right angle. The slope of RK is going to be negative 4 minus a negative 1 over 3 minus 7, so that ends up being negative 3 over negative 4, which is 3 over 4, and then the slope of BK is going to be, where am I? Negative 4 over 3 again. So I have my 4 slopes, and then we're going to find 2 distances. Let's find KR. Doesn't matter which one as long as they are consecutive. KR is 3 minus 7, so that's negative 4. Negative 4 squared plus negative 4 minus a negative 1, so that's negative 3 squared. 16 plus 9, he's going to be radical 25, which is 5. And then BK is going to be negative 4, right, where am I, BK, so negative 4 squared and 3 squared, negative 4 squared and 3 squared, again that's radical 25, so that's 5. So we have all our work shown here. What we need to do is to write concluding statements, and I'm going to go to a blank page to do that, but you probably have space on here in your example underneath. Alright, so here's what we're going to say. We're going to do like 3 sentences here. Our first statement based on the slopes says opposite sides are parallel, so bark is a parallelogram. And then I know I said 3 statements, but we can do this in 2. The second statement is consecutive sides are parallel and equal, so bark is a square. So it takes a little more work to prove that a quadrilateral is a square compared to a rectangle and a rhombus. And I think we're going to save the trapezoid. We'll do that together in class.